What, those 12 inverse problems on Friday? You did those in class. Was there anything crazy that you couldn't figure out? 7. Sorry. Which one?
No. We got.
Oh, I thought you were. Which one? Was there one at all in particular you wanted to look at?
No, sir. No, but like you said, like on a test, you won't care if it's x squared over 2 minus.
Which one is that? Let's just show you.
Okay, number 10. Do number 12, actually.
Would you mind reading it to me, please?
Oh, it's y equals the root of 5x minus 8.
Okay. Flip-flop them. Cube it. Add 3. Divide by 5.
So, yeah, like I said, you wouldn't care if it was that way.
Oh, it's in like 1/5?
Yeah, instead of like
they probably wrote it as
x
cubed over 5 plus 3/5. Yeah, this is perfectly fine. Absolutely fine. You do not need to break it apart to fraction, because this already has a common denominator for both of them. You don't have to worry about it. So yeah, no, that's cool. Let's try them.
13, please.
Would you mind reading it to me? I don't have it in front of me, because I forgot to walk my desk.
F of x is equal to x squared plus 7. Look at this really wrong, and I don't know why.
And did it have a domain restriction? Did it have like for values?
Yeah, x is greater than or equal to 0.
Okay. Here's the reason why they put that domain in here. So to find the inverse of this, obviously we just do x becomes x equals y squared plus 7. Okay. Subtract 7. Take the square root. The reason that there's a domain of x values have to be greater than or equal to 0 to start with is that they were only looking at 1/2 of this graph. Okay. The parabola of this, in order for it to have an inverse, it's something we'll talk about in the next day or two. That's what that graph would look like for x squared.
Okay.
Since they're only looking at 1/2 of the graph, it actually has an inverse. If it was on both sides, remember when we did this last year, we had the horizontal line test for inverse, it wouldn't pass.
Okay.
So since this one did, it had the inverse that looked like this, which means that there's a imaginary line, y equals x, that goes through it, that all those points are symmetrical on. Pretty fancy.
Yeah.
That's why they put the restriction in. Okay. Anything else crazy? One of those things. Well, yeah, that's why I did it on Friday homecoming, saying you guys won't do anything otherwise. True.
You're really
I had to write an essay, and I did it this morning.
I used to have to do that also, where I had to write papers. I would just, back in the day, we had things that were called word processors. It looked like a small, it was like a typewriter. It was a typewriter that had a hard drive on it. It had these little floppy disks. So it had a little screen that was no bigger than, it would hold like 4 lines of text that might have been like, I don't know, just a little text amount. So you type your whole paper on this little screen, you could save it on the disk, and then it would print it all out for you. Well, I would just wait to do my papers the day of and go sit in the study hall where we had honors. We would just sit in the wing. We had the band room and type my paper that day and hand it in by the end of the day. I didn't want to do it anymore. It's amazing.
Yeah, it's just really
It's clashing.
Yeah.
It's like really like, it's kind of hurting my eyes actually, like the tie is like hurting my eyes.
Then don't look at it.
It's pretty tricky.
But it looks good.
No.
Make sure your name's right. Pass it up, right?
Wait, I thought you said you weren't passing it up.
Oh.
Yeah. Are we just passing this up?
Oh, yeah, never mind then. Okay.
It's like
That's right, you just put them right there. Yeah, you're right. I'm sorry, I forgot about it. Hi, how are you? Good to see you. Yeah, no worries, no worries. So let's talk a little bit about how this is going to work with when we talked about this last year. When you guys worked with the inverses last year, it was more or less written out as just y equals some linear equation. We did a couple cubics, a couple polynomials, nothing too fancy. What's going to change a little bit this year is that the way that it's worded is going to change. Okay. the way that we verified last year was a little bit different than how we're going to verify it this year. It's the work itself is not difficult. Just the process just is going to look different, but again, it's the same thing. I don't know how else to explain it. Is that just like a bunch of the stuff we've done so far in pre-calc, it's a rehash of Algebra 2 in a different language. That's it. It's just gotten a little bit more technical. All right. So like we did this on Friday. How'd you find the inverse of y equals 2x minus 4? What would you do? Switch and then resolve. So if you did that, you'd switch it. You get x equals 2y minus 4. Pretty simple. Add 4, divide by 2. And there would be your inverse. Well, one of the things that we did not talk a whole lot about last year when we were dealing with inverses is what did it look like graphically when you did that? What did it mean about what the ordered pairs were looking like? Bless you. So if we look at it in terms of, what was that? Y equals 2x minus 4 and y equals
X plus 4.
Thank you. If we look at it in terms of those, let's look at the calculator. And I've been working on figuring this thing out, so hopefully I'm getting the look not as bad. There we go. Take your calculator. We want to show you something. See better. No, I'm changing. I'm going to change the homework outcome just ever so slightly. Yeah, mine's about the same, but I want to emphasize just one style today. Okay. So what I figured out with these calculators is how you switch between some of your stuff. If you're on the main screen, you're on the main screen. Of course, mine just went right to this because I hit that. Let's just go to the home. If you're on you hit the home button, you get that screen. Everybody agree? Yes. Just select graph. Okay. I think your value might have the f of x part. It probably shows on the bottom of the screen. Mine's just up on the top. This is just a newer operating system of the one you have. They're very similar. Okay. So what I want to do in your f of x thing is we're going to type in those two equations. First one we're going to put in there was 2x plus 4. Oh no, minus 4. Excuse me. Okay. And hit enter. We should get one line. Then we're going to put in another one. In order to do that, we had to hit tab. Finally figured that out. I'm so proud of myself.
That would have been nice to share.
Oh, well, I just figured it out.
It's very hard to figure it out at first.
I'm sorry. And then the other one was, okay, so I'm going to create the fraction. You guys know how to create a fraction in this one? Yeah. Second divide creates that fraction bar.
Control.
Oh, yeah, sorry, it's control. I'm so used to the 84, it's second. So it's control, divide. And we'll do the x plus 4 over 2, yeah. I did. Oh, I did? I swear I hit the button. There we go. And we'll hit enter again and we should graph it.
Mine does not look like that.
I really like
It already came up to that, so that's how I don't really know. When I was graphed.
Sorry. Hey, I was just figuring it out too. It's okay. What I did there is I went to your home screen and I just went to add page. So I created a new page. I'll show you how to back out, delete all the old stuff. What's that?
How do I delete?
Oh, this is where it's go back.
What? Because then it comes up with these stupid symbols. You don't know how to get out of it.
Oops. Will you just press 3 real quick? Do that for me real quick?
Hit 3.
Yes, the number 3 and enter. Should have worked. I can't see
Why
what
does it say negative 7?
because that's
Sorry about that. I accidentally tried to save something. But yeah.
that's what it says. You can't put it on a perfect 10.
Because that's minus 4, not x
Can't
plus
do
4.
it.
It was x plus 4 was the second one.
Just can't. Don't ask
All right.
questions.
So what's happening here, I'm going to put one more graph on here.
She's right.
You didn't bring it up there?
No, she did.
Minus 4.
Oh, she's writing it down, honey.
I'm going to hit tab, put one more graph on here. The other graph I'm going to do is just y equals x. What? Yeah, convenient how that works sometimes. What happens here is that when you have inverse functions, every point that lies on, oops, see if I can get this to drag over. Oh, this doesn't drag. Every point that we have in here, let me snapshot. There we go. Right on it. Every point that's on this one, the red line, has a symmetric twin to this side. Okay? What happens is that they are all bound by that line y equals x. They may not be the exact valued ordered pairs, they are reflected over that line. So if this point here was, if it was 2, let's see, what is 2 plus 4? 6. What's 6 over 2? 3. So this ordered pair would be at 2, 3 on the red. If it was on the other one, what's 2 times 2? 4. Wait, what did I do 2? Yeah. I'm looking at the wrong equation. Anyway. But what happens is you get this, I won't say symmetry, but it's a reflection over that axis. They're flipping over each other. When you look at that graph when we talked about the x squared, and then square root of x, they flip over each other. They're reflected over that line that comes in this way. It's just ever so little different in how we explain it from what you guys did last year. You're still changing x and y and solving, okay? But what we're going to do is we're going to write the definition of a function, or inverses, in terms of function notation. That's what changes here. We might have done this. Do you remember writing it like that? F the inverse? You guys did that last year? All this is saying is that when we have these inverse functions, you substituted one for another. It's a composition of it. You're taking f and g are two functions. If they are inverses of one another, if you take the g equation, substitute it into the f, simplifies out, all you get is x. When you do the other way, you get the same thing. You guys did that last year. That was nothing new whatsoever. What's going to be different, like I said, is that they're writing in terms of functions. That's it. Okay? So when we find and work with an actual algebra, excuse me. Oh man, I'm starting to get. When we take, oops, we take f of x equals 4x, and I want to verify that f of x and its inverse, when I substitute in one for one another, I should always get x. But the first thing we have to do is find the inverse. So the inverse of 4x, if you think about it, remember you're switching x and y. the inverse, just like you said, you 1/4 x. Or you can write it as x over 4. Does that make sense? It's nothing new. But what they're asking you to do is find its inverse and then verify it algebraically that they are in fact inverses of each other. So if my inverse is x over 4, what they're saying is f of prime of x. Well, remember, that means take the x over 4 and then surround it with the f equation. Does that equal x? Yeah. What's wrong? What's the point of it? Just, that's how you verify that it actually is its inverse. Not really. Well, I'll show you guys the graphing part of it tomorrow. It's pretty easy, but I want to do the algebra today. This, like I said, the algebra stuff is way easier because you've done it. Okay? I figured on Monday, might as well start with the stuff that's easy. You guys can do without a problem. And then you do the other way. You start with the f of x equation, and then you surround it with the inverse equation. It means prime. F prime, it means it's the inverse. Okay. Good question. I wrote it and didn't even think about telling you guys what that meant. This f prime, this part right here, that means inverse. Inverse of f. I didn't even think to say that's what it was. Then when you see that prime, that tick mark there, that's just what that means. Yes, sir?
So will it always equal x no matter what the inverse?
If their inverse is yes. If they don't, double check your math. You might have wrote down -4 instead of +4, or something like that. That's fine. But they should verify out. Okay. And then, like I said, composite of function. That just means you start with the f of x equation, and you surround it with the other one, and that's how you verify. As a composition, written out like that.
So it just has to equal x.
Has to equal x. Has to equal x. It has to equal x. That's how it verifies that it works. Okay? The other way that we look at it, again, the other example here. Oh, we just did this. To verify, excuse me, in order to check to see if some of these are inverses of one another, basically all we're doing is we're taking this f equation, 5 over x minus 2, and we're going to check, does f of g of x equal x, or f of h of x equal x. That's what that is asking us. That's what that means. Which of the functions is the inverse? Well, if it's the inverse, that composition has to work, and it has to equal x when you're done. If it doesn't, you double check it, and then if it really didn't work, then you know it's not an inverse. So when we're looking at it, remember how you work with these compositions. Write down the innermost part of it, and then surround it with the rest. Bless you. If I start with the first one, I'm going to write down the g of x equation, which was x minus 2 over 5. And then I surround that with the f equation. So this is minus 2 all over 5. Okay? Which means you have some simplifying to work on. Well, what's the first thing you have to worry about? Well, if you look at that bottom part, you have a fraction minus a whole number. So I have to do a common denominator there. Okay?
So
Yeah, I'm going to move this out of the way.
listen,
Yeah, but
so I just did the inverse in my head, and I know it's not G.
okay.
So when I look back, so just prove that's not G.
Yeah.
Even though I know your sheet's like.
Yeah. Fontana and I were talking about that today. This needs to be a common denominator of 5. Are we okay with that? So that means I'm going to say that this is x minus 2 minus 10 over 5.
Yeah.
Is it okay with that?
Yeah.
What I did there is I just turned this 2 into a 10 over 5. Real easy. And then up here is a 5. Now, I don't know if you guys probably, some of the regular Algebra 2 classes might not have spent a lot of time with, these are called complex fractions, fractions over fractions. Yeah, and this is basically all this is. Because in order to simplify this out, you get x minus 12 here. Are we okay with that? What I'm going to do is that it's x minus 12 divided by 5 over 1. Does that make sense what I'm doing? We're creating that double layered fraction, which is the same as saying 5 over x minus 12 divided by 5 over 1. Splitting it apart, go horizontal here. Remember, it is, but once you do a couple of these, it's really fast, because now what do you do with that second fraction? You flip it. So you wind up with and just like I said, we know it's not an infinite.
Is it ever going to be like times 2 over linear or the inverse?
It might, depends. It might be like, which one of these is the inverse, all, some, or none, or, you know, something. Well, it can't be all, but it could be one of these or none of these. It could be something like that. If I do the same thing with the other one, we go, can I go back to the other first page, what they had, the h of x? The other one said start with the h of x equation. And surrounded with the
I
I.
can cross multiply, so that's why I just got each other to do that. Oh, that's what you, okay.
Fraction equal fraction, cross multiply.
Okay.
Start with the h of x, and then surround it. Oops. Minus 2 over, what was it? Over 5? Okay. So when I simplify that one out, I'll put that on another sheet. There we go. That lower part, that lower denominator, I don't have to worry about anything because I have 2 minus 2. Okay? So you wind up with 5 over 5 over x. And this is where I'll start to flip things out horizontally, because this is the first part of the fraction. Here's the other part of the fraction.
So 5 over 5.
Why did we get x then?
Wait, I got X. No, I got X. Yeah, I just did it like that because Mr. Sweater, when we were dividing fractions,
Yeah.
he said you take what's under the first.
Yeah.
So it would be 5 over X. Or X over 5 times 5. Yeah, wait, that's
Such an
what
idiot. I totally forgot that. I flipped the wrong. I thought the top was the fraction part. Yeah, I'm sorry.
You confused me.
I confused myself on this one. Yeah. This is the top numerator. I got lost in which one was the numerator and stuff here. Sorry about that. Yeah, it winds up with,
X.
yeah, 5 divided by 5 over x, which is 5 times
No.
x over 5. And there you go. I flipped the wrong fraction. Oh, Mondays, you're fun. Believe it or not, I usually screw up before I get to you guys, and I don't normally screw up by now.
Wait, so then the other one?
No, it's fine because we had that weird fraction on the bottom. We had double fraction. We had double fraction. We'll do another one. Let's see. me get another one here. Is this the verified one? What's that? Oh, no. I just started.
Wait, you make them not long?
We both do. We're just started talking about it today. So here's another one of those.
Is it gonna be like a quiz, but like with this stuff that adds?
Yeah, like I said, I just started to look at, what should we put on there and stuff like that, so.
I'm trying to get another 89 or higher, but.
So we'll do this one. We'll verify that these guys are inverses, okay? We're going to verify that these two are inverses of one another. Which means we have to check and see, is f of g of x equal to x? And then is g of f of x? That's what we're checking, guys. That's what we're looking into in terms of the composite. If the composite works out, then we're all good.
What's the original problem?
Hmm?
What's the original problem?
The original one? That's it. It's the verify that they're inverses. So let's see.
Oh.
So I kind of gave us a worst case scenario because of all the fractions.
Yeah.
Okay? So what we're doing, in the first one, we take f of 2x plus 3 over x minus 1. Okay? That means in the f equation, everywhere I see an x, I'm going to replace it with that. Okay? So that gives me that. Okay? The value, I took the values of x and I replaced it with that second fraction, that g of x fraction, that 2x plus 3 over x minus 1. Okay? So it looks pretty bad, but kill puppies. Basically, you wind up having to simplify two parts.
It's so close.
What's going to be the common denominator there? X minus 1. Okay. The numerator, well, this fraction had the x minus 1, so it's 2x plus 3. The other one needed an x minus 1. So we just multiply it in. Yes, sir?
Oh, you forgot to multiply it.
Where?
This,
Where?
we got this. Just go and play touch. Just go and play touch.
I haven't done. I'm doing f of g of x. Are you doing this one? Oh, you were looking at it underneath it here. I got you. Well, I'm just working on the first part of it. I'm just doing that one first. Okay. Does that make sense? I'm just doing the first part. I see what you're saying now, but you thought I wrote the wrong one there. I got you. So, does everybody see why I had to put the parentheses around the x minus 1 next to the 3? Because it needed the common denominator. So then you wind up doing the same basic idea on the bottom. Common denominator will also be the x minus 1. We have 2x plus 3 minus 2 times an x minus 1. Like I said, it looks like it's awful, but really isn't that difficult to do. So we have 2x plus 3 plus 3x minus 3 all over x minus 1. I'm gonna go ahead and flip the bottom fraction right off the bat, so it's one less step that I have to do. Does everybody agree that this fraction part here gets flipped and brought up?
Yeah.
Okay. So I'm just gonna do that right away. And then I'll do the simplifying here in a second. So as you can see, the x minus 1s will drop out. Those terms, x minus 1 and x minus 1, they will go away. I can't do that yet until I simplify. These are terms. Okay. Those can drop. Up here we have, what's it, 5x. 3 minus 3 is gone. 2x and 3x. Here we have 2x plus 3 minus 2x plus 3. Plus 2, sorry.
How are you 5x?
I'm combining like terms right here.
Oh, negative 3.
Okay? And then here the 2x's drop out and I get a 5. So it winds up 5x over x minus 1 times x minus 1 over 5.
Why can you not drop out
Well, I am now. I'm showing you why we can.
5x over x?
And the 5's drop.
Alright, there we go.
Okay?
That doesn't do the other one?
Yeah. It's going the other way around then. That's all. Where'd I lose you?
Too much.
Like, okay, so 5x
Mhm.
and 5x over.
For real.
Over the x minus 1.
But how do you?
We had the x minus 1s from the original because that was the common denominator. And then when I went from here and I flipped it right away, the x minus 1s were over one another.
Yeah, and then.
Oh.
On the bottom then, this wound up being the 2x's dropped. And then we had 3 plus 2.
Oh.
You want me to go through the other part of that?
Yes.
Go walk through that one too? Okay.
So 3. Oh, okay.
Usually what'll happen here, sometimes you'll miss that sign, -2, -1. Is that what it was?
3 plus.
Okay. Let's do the other way. G of f of x, which means we verified the 1. So now this way, we start with g, and we're going to surround it x plus 3, x minus 2. So we take the x plus 3 over x minus 2 and substitute in the g of x equation. Okay? We only know going one way. In order for it to be truly defined, they have to go. Yeah.
Are there any cases where they don't go both ways?
Well, I don't know. Yes, it could be. But I think most of these things, when they say verify that they are, it should work. Unless you do something like where I actually almost forgot to add the 2 together instead of multiplying out the wrong way. Yes, sir.
So if like for the f of x, if you get like 5,
Mm-hmm.
you don't have to do the g of x, right? It's like it's
Oh, it should equal x.
it doesn't. You have to
Double
keep-
check it, because if they're telling you to verify that they are inverses, that means they probably should be inverses. You might have just mapped wrong.
Okay.
So now we'll do this one. We get 2 times the quantity, x plus 3, x minus 2, plus 3, awful, over okay. And you can go on from there. It's just
You're trying to give us a set of the
change. It's not possible.
Excuse me.
So you gotta put.
It is, yeah. It's my son wasn't feeling well earlier today, so I don't want to do graphs yet today.
Oh, thank you.
So let's just leave it with where we're at right now. With
Yeah. I don't think he wants to.
I don't want to.
I just,
All right.
you just do that.
What do I want to do?
Okay. So let's see. We get to well, the bottom one's easy. We have an x minus 2. Okay.
Why is the minus one always
Yeah, the original from the original there. It's just the x minus 4. Okay. All right, so distribute through. We're gonna get x minus 2, 2x plus 6.
Forgot the minus.
Okay, and then this one will be a 3 times an x minus 2. Okay. I multiply 2, it's just going right in. Remember, when you're multiplying fractions, you multiply numerator together, denominators together. When it's 2 times the fraction, it's just 2's the numerator, 1's in the denominator. That's why it's just 2x and a 6. And then I brought up the common denominator of the x minus 2 next to the 3 right off the bat. Okay. So now I get, numerator gives me 2x plus 6 plus 3x minus 6 over x minus 2 times, well, I know it's going to be an x minus 2 over x plus 3 minus x plus 2. You're just kind of like, yeah.
I'm just gonna take your word.
What'd I do wrong? Did I do anything? We're okay? Okay. So now we wind up with 5x. And can I just do this right away?
Yeah.
Okay, so I have 5x over
What? I got 4x.
4x.
You math wrong.
You math wrong. What's 2 plus 3?
4.
Nice project, just 5, failure.
No, no.
You see how to do it?
What was it, 2x, or so you have x plus 3 over x minus 2. Okay. When you multiply fractions together, top goes to top, bottom goes to bottom. That's why it's just 2x plus 6 over x minus 2. You math wrong. Hey, guys, this is where... I'm just showing Jenna that again. What happens here when you multiply fractions, if it's 2/3 times 1/4, you multiply straight across, right? This is 2 times 1, 3 times 4, 2/12. Okay? If I take a whole number times a fraction, what's underneath the 2 that you don't see?
That's 1.
If it was a 2, what would 2 over 2 be? So this is why you get 2x over y. It's the exact same idea when it's 2 times It's the exact idea where you're just multiplying numerator together, denominator together. You do the same thing, okay? That's where we got 2x minus 6 over x plus 1. Does that make a little bit more sense?
I don't know where you got the last part from.
Well, what happened there, Jen, is that you probably got once you mixed up that top part, everything else fell apart.
Cause like I got the other side of it, but I didn't get the.
Well, when you get to here, if you once you distribute the right way, no offense, you get 2x 6, 3x minus 6.
Also, okay, never mind.
You get X.
Yeah, I was looking at
I had,
this, not
because it was just a plus 3, that common denominator was the x minus 2.
Alright,
Let's pick a couple of these to look at tonight.
let's pick.
Excuse from the rest of my
No.
I'm bad.
With who? Don't worry.
What I want you guys to do tonight is just verify that they are inverses. Exact same thing we just did. Okay? Looks like I only have. There's only 2 fractions. Okay? I want you guys to just verify that these guys are inverses just the same way we just did. This is 1, 9. It's page 99. I'd like you to do just numbers 14 through 24. Just verify algebraically. I think that's spelled incorrectly. You're basically doing this.
Sure. You just don't do it.
That's all you're doing,
The
guys.
second half.
I want you just to show algebraically that they were. Okay?
15.
If I'm not. Oh, evens. Did I say evens?
Oh.
Sorry.
You did not say evens.
There, making your life a little bit easier. I just made your life half as complicated.
Yeah.
And we didn't.
But we're not.
Yeah, we did.
Okay.
I didn't write it down.
Did we do 20?
We'll go a little bit more into this tomorrow. Obviously, probably a lot more into this tomorrow with the graphing part and just a couple of those little things, like some domain stuff. How you can rewrite it with different domains. It's really going to be simple to move through. Okay? It just looks weird.
Where do you do your
You guys got questions? Just call in anytime, all right?
I can't do all that.
Oh no, I have to because I'll turn my TV off and I'll put it in like standby or whatever, and then I'll throw my phone across the room.